Okay, symud ymlaen I gola, refraction of light. There's one that defines the refractive index, which again is not given explicitly in the data book, but you can work it out using Snell's law. But I'll just define it anyway. So n is the refractive index, and that is equal to the speed of light in a vacuum over the speed of light in the medium. So mae bod tro mynd I fod, mae hwnna bod tro mynd I fod yn llai na hwnna. This is always less than this one. So n is always going to be greater than 1. And then mentioned Snell's law there. I just newid lliw pink. So Snell's law, there's two versions given. N1 V1 is N2 V2. So if you're given velocities, use this one. And the refractive index, cofiwch, N for air is 1. I just rhoi hwnna fan with. N for air is 1. And then if you're given angles of refraction, then you use the other version of Snell's law. N1 sine theta 1 is N2 sine theta 2. Coming from 1 into 2 every time. So if it's more dense to less dense or less dense to more dense, then cofiwch bob tro coming out of 1 and into 2 or towards 2. I'm going to special case ar gyfer for this equation, if we're talking about the critical angle where the wave is moving from a more dense to a less dense medium, then N1 is going to be the refractive index of the core or the thing that it's moving from. Theta 1 is going to be the critical angle, in which case theta 2 is going to be 90, so sin theta 2 disappears, so it becomes N1 sine theta z is equal to N2, and then you can rearrange that to get theta c sine to the minus 1 of N2 over N1. So it's always going to be a ratio of these refractive indices. Beth sy'n handi ydy, os ydych chi'n siŵr os bych chi wedi ail drefnu fan iawn, you get a math error if it's greater than 1. So it's the small number over the big number every time.